Alright, so welcome back to another lesson for calculus, and so today we'll be learning antiderivatives and indefinite integration. And so you're gonna use these two a lot for Riemann sums, to be able to find the area under the curve. Later on in the next chapter, or in this chapter in the next section, you're gonna be able to learn how to find the area under here, but you're gonna have to use the antiderivatives to find it. So, alright, so let's get to it. So first of all, antiderivatives, basically, so remember at the beginning when we were doing derivatives, right? So let's say, what was the derivative of, right, the derivative of x cubed, right? So that was 3x squared. So you remember you bring the power down, right? And then you subtract 1. So basically antiderivative is if before we were going like this, now we're just going backwards, right? So here, so that's the antiderivative, but for the indefinite integration, you have to add a plus c. Because over here, if you were finding the derivative of x cubed plus c, this would become 3x squared. But the c, because it's a constant and it doesn't have an x, it would just become 0. So you have to add the plus c because it could have like any constant. So there could be so many functions to it. Alright, so now let's go into finding it, right? So first of all, I just explained that was it. This is just the notation that you're going to be finding for. It's basically, it has this like S curve, and then it's going to tell you, and then it's going to give you a function, right? And it's going to have dx. That just says find the antiderivative. But remember, if there are no numbers here, that means it's indefinite. If, let's say, it had from 0 to 3, that's a definite integration, and so then that changes it, but we're doing indefinite, so don't worry about that right now. Alright, so there are some properties that you're going to need to know. So first of all, here, these are the three. So if we're finding the antiderivative of a constant, so it's the constant x plus c, and then also if you're finding the antiderivative of a constant times a function, you can just take that constant out and find the antiderivative of the function. Over here, if you have two of them added together, you can just split them up and find the antiderivative of one plus the antiderivative of the other one. But you can't. Let's say if it was f of x times g of x, you cannot split them open. You can't like split them. Oops, sorry. You can't do that because that's wrong. That's not one of the properties. So remember, it's just for adding, so addition and subtraction, but not for multiplication or division. Oh, and also remember your derivative. So remember, derivative cosine turns into sine of x, right? Derivative, oh my bad, negative sine of x. So, and then derivative of sine of x turns into cosine of x. So likewise, if we're finding the antiderivative, so let's say we're finding the antiderivative of sine of x, so like, what would give sine of x, right? That would be negative cosine of x. You have to remember, because the derivative of cosine of x is negative sine of x, and then you're multiplying by a negative, so it turns positive. So you're gonna have to remember those. And let's just do one over here. So here, so we're finding the antiderivative of 3x, right? So first of all, you're gonna have x squared 3/2 plus c. Alright, so that's the answer that we had. And the way that's the way I do it first, is I look at the power here. See, here I have a power of 1. And to find the antiderivative, you always add 1. So that's how I got 2. And then I'm thinking, all right, so if I bring it down, what would give me a constant here of 3? So then it would be 3 halves, because if it would be 3 halves times 2, that just gives 3, right? So that's what we want. Remember your plus c, don't forget that. So now we're going to work with the second one over here. We can split it to like this, plus. And so what's going to happen is we're going to do, again, the way I do is x squared 1/2 plus c. I'm going to call that c1 plus, this is just 2x plus c2. All right? So now we can add these up. So it'll just be 1/2 x squared plus 2x plus c, right? So, and I'm gonna label c3, which is equal to c1 plus c2, because all these c's are just constant. It's like saying like c1 is 1, c2 is 2. So I'm just saying c3 is 3, right? So 1 plus 2 equals 3. Since they're constants, you can add them up and you'll be fine. So this will be our answer. So this is pretty much it. It's actually really simple. Later on in the other units, it's going to get more complicated. And you're going to use this to be able to find the area under a curve using rhyming sums, Simpson rule, all that stuff. So, see ya.